Welcome to my presentation. In this presentation, let us try to see how we can use the properties of determinants to solve simple example problems. This time, one of the properties of determinants is telling us that if A is a square matrix, then if A is a square matrix, then the determinant of A is going to be the same as determinant of A transpose. Okay, so that is one of the properties of determinants, and we will prove this property by taking a simple example. And in this example, let us say we have A as a matrix, and the elements of this matrix are 2, 0, 5, and then 4, negative 1, 6, and then 3, 2, and 1. Okay, so we want to prove this property, and then to do that we're going to follow the following steps. Step number 1, we want to find the determinant of A first. And then here, for convenience sake, we will travel along the first row, and when we do that, we will say, according to the sign convention, the first element will take on a positive sign, the second element will take on a negative sign, the third element will take on a positive sign. So when we try to find the determinant of that given matrix, we're going to travel along the first row, and when we do that, we're going to write the minors of each one of those elements. So this is going to be equal to 2, the minor of that, which is going to be negative 1, 6, 2, and 1, and then the second element is minus 0 times the minor of that, which will be 4, 6, 3, and 1, and the third element is 5 plus 5, and the minor of that is 4, negative 1, 3, and 2. And now we are now ready to expand this out and then see what we get. This is going to be 2 times negative 1 times 1 is negative 1, minus 2 times 6 is 12, minus 0 times 4 times 1 is 4, minus 3 times 6 is 18, plus 5 times 4 times 2 is 8, minus of 3 times negative 1 is negative 3. Therefore, this is going to be 2 times negative 13. Then 0 times any number is going to go to 0, so therefore we will not even write that, plus 5 times 8 plus 3 is 11. So therefore we come back here and then say 2 times negative 13 is negative 26, plus 5 times 11 is 55. Therefore this value comes out as equal to 29. So the determinant of A is 29, and what we need to prove now is determinant of A is same as determinant of transpose of that matrix. So in this next step, step 2, we're going to find the transpose of the given matrix. If the given matrix was 2, 0, 5, 4, negative 1, 6, 3, 2, 1, isn't it? So let me write that here. The given matrix was A was equal to 2, 0, 5, 4, negative 1, 6, and then 3, 2, 1. This is our matrix, the original matrix. And to write the transpose of this matrix, we said we're going to transpose the rows into columns. So we take the first row and then transpose it as columns in this transpose matrix. So 205 is the row, and that becomes the column 205, and then we do the same thing for the rest of the rows. 4, negative 1, 6 is the row, that comes down and that transforms to a column 4, negative 1, 6. The third row is 3, 2, 1, and that is going to be the column in this transpose matrix, like that. So we got the transpose matrix, and to find the determinant of this transpose matrix, if that number, if the value comes out the same as 29, then we have proved this property to be correct. So here again, for convenience sake, we will travel along the first row, and then according to our sign convention, the first element takes on a positive sign, the second element takes on a negative sign, the third element takes on a positive sign. Therefore, we take the element 2, we start with element 2, write the minors of that, which are -1, 2, 6, and 1. The second element is 4, and it takes on a negative sign because of the sign convention. And then the minors of that are 0, 2, 5, and 1. And the third element is 3, and the minors of that are 0, -1, 5, and 6. So let us expand this using our determinants property and then see what we get. This is going to be 2 times -1 times 1 is -1, and then 6 times 2 is 12 with a negative sign. Then -4 times 0 times 1 is 0, minus 5 times 2 is 10, right? Plus 3 times 0 times 6 is 0, minus 5 times -1 is -5. So we want to be careful about the signs. So therefore this is going to be 2 times -13, right, minus 4 times -10 plus 3 times +5. That is what we have. So -2 times 2 times -13 is -26, and then -4 times -10 is +40, and then 3 times 5 is 15. When we simplify this, -26 plus 40 plus 15, the value comes out to be 29. Therefore, the determinant of the transpose matrix was also equal to 29, and therefore, as you can see here, the determinant of A was 29, the transpose matrix was also 29, and therefore this property is true. So therefore we can come back here and then say in step number 3 that the determinant of the matrix A is same as determinant of A transpose, right? That is that we have proved this property, and this is pretty much saying that finding the determinant along the row or along the column is the same. This is exactly that property. So in my next presentation, we shall look at some more examples to see how we can use the properties of determinants to solve simple example problems.